Thank you for the introduction. Yeah, I'm here to talk to you about the Quantum Climate Challenge. Yeah, so it's our annual challenge we host as Deloitte. Yeah, and I'm Niklas, as I was already introduced. I'm a senior consultant at Deloitte Consulting Germany, or Deloitte Germany, and part of the Quantum Link team, which is a quantum team in Germany. We have consultants all around the world, but I'm from Germany. So, the Quantum Climate Challenge. We all know that we are living in a time of the climate crisis. We have a lot of challenges going on there, and we also all are excited about quantum computing, right? So maybe we thought we can combine this and focusing on topics with quantum computing that could help us as humanity fight the climate challenge. So we thought of another challenge, the Quantum Climate Challenge, to do that. And for that, as like Tanguy pointed out this morning, we also have 3 topics. Optimization problems, where we think about how can optimization problems help to fight the climate crisis. Examples could be flight trajectories or load optimization. If I load a ship better, I basically have to drive less often and therefore can save CO2 emissions on the roads. The second part is quantum simulation. As always, there we can, for example, focus on batteries, look how we can make batteries better, and therefore enhance electric vehicles, which probably will be the future, because we will not get rid of individual transportation, and therefore we need CO2 neutral solutions. And the last part, quantum machine learning, which will be a lot about today as well. And another example will be the grid management, where we have to basically take into account that we have renewable energies now, which behave differently. So our old grid management systems don't work anymore. And with renewable energies, this grid management gets way more complex. So we would hope that quantum computers could help us there. But that are just like 3 introductory topics. I will talk about a little bit more about that later, about topics we actually did. But now the question is, why do we do it? What are our goals? What's the purpose of the challenge? So we want to drive engagement across disciplinary boundaries. So why should we not use different people? Like if you are a chemist, you might not know about quantum computer. If you know about quantum computer, you might not know about chemistry. But if we put it together, we might be able to create new batteries. We want to perform applied technology scouting. The question about quantum computing is often like, how good is it? What can we do with it? And what better way to do that, to find out, than to let a lot of people look at it and find out new ways to use it. But like getting people involved in is often a challenge. So we want to create authentic learning experiences. With authentic learning experience, you can actually learn how to do stuff, and not just in theory, but with an actual problem. That's also why we wanted to focus on climate. And last, learning opportunities at intersections. Basically, going back to point 1, if you talk to other people, if you talk to someone else, you will probably learn something. So, but how do we do that for our challenge? Basically, as hinted on already, we invite quantum enthusiasts, but also sector specialists, and last but not least, climate experts. And getting these people together, we can create new solutions, hopefully advancing the fields, getting other people excited about quantum, and have interdisciplinary teams. To help with that, we of course have a platform where people who sign up alone for the challenge can find other people who signed up alone, and they can create a connected team. Last year, for example, we had a team of 2 software developers, a quantum enthusiast and a chemist from 4 different countries joining up a team and actually making it to the final and winning a prize. The participants receive access to real quantum hardware. So we have hardware partners, AWS, NVIDIA, and IBM, who supply hardware access for all the participants. so they can actually do technology scouting and not just like work on the simulators on their own laptops. The quantum crisis actually is a great field for providing authentic learning experiences, because we have a lot of open and challenging problems, and we can provide this to the participants. And lastly, we also want to educate them, because we all know we don't have enough people in the quantum technology field to explore the possibilities. So we want to get more people in, and therefore we have enablement sessions. And the solutions in the end also are interesting for the jury, who can look at it and learn from us, and for us as well as host. So what did we do? We did do in 2022, we did a flight routing challenge, where the big open challenge was basically, how can we do flight routing in Europe with quantum computers? Because right now it's done manually by hand, it's super complicated, we can't do it on classical computers at all. So yeah, why is there actually a problem with flight routing? I mean, yeah, the best flight routing is no flight at all. Just keep them on the ground, take the train, everything's good. But unfortunately, we are not there yet, so people will fly. So these contrails there, they are actually really, really bad for the environment. But they only develop on certain conditions. There was a new study released recently, which says that 35% of climate impact of flights is done by contrails. So the idea was, how can we prevent that in the challenge? And the participants got lists of flight and had to think about collisions and anything like that. So that was that year. I also have a figure from the German Aerospace Center. You see, like the purple line is the line, the direct line, and the dotted lines actually are the more climate and environment-friendly lines, where you see that's a huge derivation there. So it's not the shortest line, because if you fly another line, you will create less contrails because of lower humidity levels in these other areas. So in 2023, so last year, we did direct air capture as a big problem. You might all know about these huge filters collecting a lot of air, going through it, trying to collect the CO2, and then storing it in the ground. You might have heard of the product in Denmark or in Germany as well right now. So that was a big problem. The more focused in version was metal organic frameworks, which are frameworks where you can switch out the mangan in here, for example, for other metal ions. And the question then is, which binding energy do we have between CO2 and this metal organic framework? Because you want it high enough so that only CO2 gets caught by the filter and not O2, for example. But on the other hand, it should be as low as possible, because you want it to be easily removable from the filter, so you can use the filter again and again, because you don't want to throw away the filter, because then you would probably not generate any benefit for the environment. So, and now the preview for this year. This is not yet public, so you get a sneak preview, basically. This year we will look at disaster prediction, and especially at river flood predictions. And now, this is the river we are going to look at. It's a river in Germany. It's called Wupper. It's a medium-sized river, which is actually interesting, because like for big rivers like the Rhine, we have a lot of data. We have a lot of data. We can see really, really easily when it will flood, when not, and prepare accordingly. For smaller and mid-sized rivers, it's way harder, because we have less data. The Wupper is actually quite nice in that regard, because it is a small river, but it has at least some degree of data. We're working together with the local river agency to provide these data to the participants of the challenge. So, I talked about climate. Why is river flooding climate related? Pretty easy, because climate change increases natural disasters. We get more floods, we get more wildfires, and all these other natural disasters. Not all, but a lot of them increased. And if we can predict when they're going to happen, we can prepare our response, we can evacuate people we can maybe even prevent the disaster. So natural disaster prevention, how is probably your next question. So this is actually like a part of the river where we have a station to measure how high the water is currently and how the flow is. And you see the orange line. If the water would go there would be a warning. If it goes to the red line, it's actually called a flood. Right now, right now on the 28th of February, you see it was quite low, so everything was good. But now, if there comes a lot of rain down in the area, we get a lot of water in it, and we will have a flood. So the thing is, we have water reservoirs as well. And that's actually, like this is the biggest one. At the same time, you see it was quite full. But it can get up to 19 billion liters of water in it. So if we get this emptied before the rain comes, because we know that there will be a flood risk, we can actually store a lot of water in there again. So we can increase, like if we know there will be a flood risk in 3 days, we can right now, where the water level is low in the river, get the reservoir empty and then get a lot of water of the rain inside the reservoir instead of inside the river. Yeah, for this timeline, you are all on time. The kickoff is next week, Wednesday, on the 13th of March. Then we will actually start the challenge. Participants will get access to all the data and all information regarding the Quantum Climate Challenge. We have then enablement sessions of our hardware partners. I will come to that on the next slide as well. And the submission deadline is then the 28th of April, so you have about 7 weeks to come up with a solution. And then the finalists are going to be announced on the 12th of May, and we have our final pitch event where the victors are invited to present their solutions and then get their prizes there in Düsseldorf in Germany. So our hardware partners, as mentioned before, are IBM, AWS, and NVIDIA. We will have different access models for them. Like IBM, we have the 127 qubit hardware access, which you can, of course, access as well anyway, but you will also get IBM credits if you make it to the finalist to access their quantum computers. For AWS, we have directly credits for everyone who participates, more for the finalists, so you can use their simulators and their quantum hardware. And for NVIDIA, we have access to an A100 cluster to provide access to these simulators for the participants. And the enablement sessions are going to be week of March 18th for AWS and IBM and April 19th for NVIDIA. So hope to see some of you there as well. And yeah, and if you have any questions, you can ask QuantumLink at Deloitte.de. And if you want to join the kickoff, I provide the QR code. The time is, of course, wrong. We don't do 2 hours. We just do 1 hour. No worries. And yeah, that's it. Thank you very much.
Thank you, Niklas. That seems like a very interesting challenge. I have a few questions actually. So you showed 2 potential use cases on the challenge, but you know how many there will be?
So we
without revealing too much.
Yeah, so we plan to do it every year. So we will see how long we can do that.
But sorry, there is okay, how many different types of challenge there is this year?
This year is just one.
Okay, sorry.
Just one type. It's just the flood prediction this year.
The flood prediction. Okay.
Last year we had chemistry. The year before we had optimization. Maybe we go back to optimization next year.
Okay. So and you mentioned the price. What is the price?
The price.
If you can tell.
So yeah, I can tell. The prize pool is 12,000 euros,
okay.
Split among the 3 victors.
Interesting.
And as well, beyond that, of course, connections to our hardware providers, to our expert jury, and we also try to promote the challenge afterwards as well, all the victors of the challenge afterwards as well.